Good afternoon. My name is Nika Durham from the National Renewable Energy Lab, and I'd like to welcome you to today's webinar on the Energy Systems Integration Facilities Visiting Scholars User Call. We're excited to have you with us today. We'll give folks just a couple more minutes to call in and log on. So while we wait, I'll go over some logistics and then we'll get going with today's webinar. I want to mention that this webinar will be recorded and everyone today is on listen-only mode. You have two options for how you can hear today's webinar. In the upper right corner of your screen, there's a red arrow. If you click on it, it opens the webinar toolbox and there's a tab that says audio. This will allow you to choose whether or not you want to listen to the webinar through your computer, speakers, or a phone. We'll have a question and answer session if time allows at the end of the presentation. You can participate by submitting your questions electronically during the webinar. Please do this by going to the questions pane in the box showing on your screen. This is accessible by clicking the red arrow again, and the questions box is in the list. You can open it to type in your questions that you have during the course of the webinar. And our speaker will get to as many questions as time allows. Before we get started, I'd like to introduce you to our panelists today. With us, we have Andrew Hudgens, Research Development Liaison for the ESIF at NREL. And with that, I'll hand things off to Andrew to get started.
Great. Thank you, Nika, and thanks to you who have joined today. So we have an exciting opportunity that we're going to be discussing. It's the ESIF Visiting Scholars User Call. And a little bit of background on the ESIF and why we issued this user call. This user call invites faculty and students to conduct research in the state-of-the-art laboratories in the Energy Systems Integration Facility. And we're located in Golden, Colorado. And if you're unfamiliar with the ESIF hosts a collection of interconnected laboratories that can accommodate megawatt-scale research and development at full power. Research in the ESIF focuses on modernizing the electrical grid and beyond, addressing integration of multiple energy systems, including water, thermal energy, and fuels. And our hope through this opportunity is that by immersing visiting researchers into the ESIF ecosystem, they will carry valuable insights and new capabilities back to their home institutions. So at its core, the ESIF encourages collaboration between government, industry, and academic institutions. And so we really feel that this Visiting Scholars User Call helps move that forward. Our intent is to focus on innovative, kind of next stage research and development in this space and really help move the thinking and the markets forward for energy efficiency and renewable energy. So, quick overview of the program. Our objective here again is to increase the innovation from research conducted at the Energy Systems Integration that advance Department of Energy's energy efficiency and renewable energy office goals, in addition to the Department of Energy Grid Modernization Initiative. So we're going to dig into these details a little bit more on the following slides, but just a brief overview. Domestic and foreign applicants are eligible to apply, and the applicants may bring up to 2 students to the ESIF to work on the project. And that period of performance is 12 months. And let's say you're in here for 10 months and you're really doing a great job. We're advancing your research quite a bit, and there's an identified need to extend. We can extend pending a review of where the project is at, what needs to and can be completed if it was extended. For funding, the applicant's institution is responsible for supporting the project and providing funding for all expenses associated with the project. So you have to have a funded project identified as you apply for this opportunity. And the work may be independently performed by your team or alongside NREL staff. And you'll see there that there is a fee associated with that. So if you have a funded project, and as you're discussing and proposing to work here at the ESIF, and there's identified need for an ESIF researcher to participate in the project, then the applicant would have to cover that staff's time. All work will be non-proprietary because this is a Department of Energy facility, and the results must be published and shared publicly. And the program timeline there on the right, you'll see the application period. While we just announced this, it is an ongoing application period. So you don't have to, we encourage you to apply early, but if you need some time to learn more about this opportunity and the capabilities and opportunities at ESIF, you have time, plenty of time to do that. Once we receive an application, our timeline is that we will review those every 4 to 6 weeks. And then if you apply and this is a good fit, you kind of meet the eligibility criteria that I'll discuss, then we'll negotiate an agreement, and that generally takes 4 to 6 weeks as well. And again, the period of performance is up to 12 months with the potential to extend pending a review. And underneath the timeline, you'll see the URL for this opportunity. So feel free to click on that, bookmark it, visit often to make sure that you have all the information in front of you. So eligibility, I mentioned that it could be domestic and foreign applicants, but the research projects must align with one of the 3 following areas. The Department of Energy's Grid Modernization Initiative. And the Grid Modernization Initiative is kind of the umbrella for the work that's done here at the Energy Systems Integration Facility. And what I'll call the GMI does is it represents a comprehensive effort to shape the nation's grid and solve the challenges of integrating conventional and renewable resources with energy storage, smart buildings, and ensuring the grid is resilient and withstanding cybersecurity and other resilience challenges. So I know many of us here at the lab and those of you on the webinar are fully aware of the opportunities that can be realized when you integrate more distributed resources complementing existing infrastructure for natural and man-made, extreme events such as hurricanes. So we saw a lot about that in the news in Texas and Puerto Rico. So it's very important to Department of Energy. So that's why we want to make sure that applicants are fully aware of the Grid Modernization Initiative and those objectives and goals. Number 2 is aligning with the Office of Energy Efficiency and Renewable Energy, again, EERE. And so that bullet is intended to be broad because we invite you to learn more about EERE, the technologies that are supported at EERE, and then learning more about how NREL as an EERE lab supports those goals through research and development. Then number 3, as its name implies, the Energy Systems Integration Facility, we're looking at energy systems integration. So we are addressing important points of integration between the electric power system and water, thermal energy systems, and fuel systems infrastructure. So it's not just looking at a technology, kind of independently or in a vacuum. How all these integrate, how you can control those, and how you can optimize those systems is what we're looking at doing here at the ESIF. Applicants must be currently employed or enrolled in an accredited academic institution. Any foreign applicants and then all project participants will be screened in accordance with DOE's policy and granted access to ESIF on a case-by-case basis. So funding and support. As noted earlier, applicants are required to secure their own funding prior to conducting work in ESIF and indicate whether funding is secured or pending an award at the time of submission. So that's very important for us and our ESIF operations group for planning, scheduling, on understanding whether you have the funding or what that timeline would be if you're waiting for funding. You must provide information about the funding source that will be used to support the team conducting the research here at the ESIF. As far as support from ESIF staff, our researchers may be available to support the project if it aligns with an existing funded project, or if the applicant includes funding to support labor provided by NREL researchers. And again, I mentioned at the outset, this is a very collaborative facility. So as we're receiving applications under this user call, we want to make sure we're identifying synergy and potential alignment with work that's going on already at the laboratory, because those type of opportunities really can then help all parties continue to advance that learning with multiple different perspectives and experience from the project team. And all participants that are selected will be supported by ESIF operations staff to ensure the proper setup and decommissioning of the project at no cost to the home institution. And we will also provide training and oversight associated with the safe operations in ESIF laboratories at no charge to the applicant. So here at NREL and the ESIF, we are very particular about our health and safety record. So we want to make sure that as you and your team potentially come here to the ESIF labs, that you're conducting your research in a safe environment. So I want to spend, there's not a lot on this page or this slide, but I want to spend a decent amount of time to make sure that you understand the components of the proposal package. And again, the URL that was on the opening slide has a link to the call itself, and so you can download a copy, make sure that you have all the information that's required in the proposal package, because we will be reviewing to make sure that your application includes each of these items that I'll discuss. So the one-page cover page, we just need a proposal, title, and abstract, and it's a descriptive title of your project, and no more than 150 words, that summarizes the topic or problem, the approach, and the expected scientific results and impact. For the research team, this will be in a table format. List the names, institution, email address, and roles of each person who will participate in the proposed activities. And also, this section could briefly mention directly relevant work done previously by the team members. And if you desire, include kind of a generic NREL researcher in the team name if you intend to work, and then we can identify the proper NREL researcher that would support your project. Research area, please indicate the area in which your project best aligns. And the slide on eligibility for the grid modernization, EERE, and systems integration. Be sure to include specific goals that support each of those three components or the objective that the project addresses. And then the ESIF facilities. We need you to briefly state which ESIF capabilities are of interest to you. And you see the URL there at this bullet. So nrel.gov/ESIF/facility tour. That facility tour allows you to learn more about each laboratory that's here in ESIF and the equipment, resources, and capabilities in those laboratories. So that is going to be a very important component of your application, is to learn more about what we offer here at ESIF and how those can support your project, because that'll allow us to find the proper reviewers for your applications and ensure that based on the timeline that you would provide us, that those resources are available to you. Then funding source. List the amount of funding by source that will support your research in ESIF. And then again, similar to listing in the table, if you intend to have ESIF researchers participate, list the amount of funding and whether the funding will be used to support the NREL researchers. So going into the body, 6 pages. For the background, we need you to define the context for this proposal by relating it to other work, both at NREL and elsewhere, including any preliminary studies. And we're looking for you to set the stage to answer the question, what is innovative in the proposal, and how does it advance the state-of-the-art in energy systems integration? So that question should be at the top of your application, the top of your notes as you're planning to submit a proposal. That's very important because we want this, again, to continue to move the state-of-the-art forward for the R&D and the studies that you're going to do here at the lab. And then there are 4 specific pieces of information that should be provided. 1 to 3 references to key publications by others that describe the state of the art in the area of research proposed. Specifically indicate areas where there are gaps in the current state of our knowledge and how you can fill those. An identification of the proposed project's connection to activities, both current and future at NREL. Then the identification of other current, recent, or past Department of Energy projects that are related to or have led to the proposal. So again, advancing the state of the art, the narrative should include the current state of the research, how your project can move that forward, how it relates to existing or previous research, and DOE and NREL objectives and goals. So we're going to need you to clearly state your hypothesis and research objectives and goals, your R&D approach and expected scientific and technical results, your key deliverables, and your schedule. And then at the bottom you saw the team's CVs, so ensure that as you identify the faculty and students that will participate, those need to be included in the application. So as we receive these, and as mentioned, we'll be reviewing these every 4 to 6 weeks on a rolling basis. And the information that you provide in the proposal package is going to help us identify the right alignment for research here at ESIF. And then that leads to our merit review criteria and the team that will review those applications. So we have 4 criteria that are each weighted 25%. So the first is alignment with the research areas. So we'd be looking at things like how it addresses the challenges outlined in the grid modernization multi-year program plan, which is part of the grid modernization initiative, or goals of a specific ERE technologies office, such as the fuel cell technology office, vehicle technology office, or the solar energy technology office. So again, as I mentioned before, learning more about ERE goals, technologies, objectives will be very important as we get to the merit review criteria. The second criteria, scientific or technical merit of the project. So we want to understand and have you demonstrate how your project will influence the results on the direction, progress, and thinking and relevant scientific fields of research. What's the likelihood of achieving these results based on your approach in your project, and the innovation and originality indicated in your proposed research? So how is it different? How does it advance previous or current research activities, and how are you going to achieve that innovation? The third, appropriateness of the proposed method or approach. So what is the feasibility of the approach, the soundness of your methodology to conduct this research? So these, again, will be reviewed by current researchers in that field. So methodology and approach is going to be very important. And then the last criteria, what's the competency of the personnel and adequacy of proposed resources? And so this is very important. Again, the team CVs, we want to ensure that the faculty and students have experience in this field, and then the adequacy of the proposed resources will be looked at closely for us to understand, based on your approach, your projected goals, deliverables, achievements, is the budget fully aligned with achieving those? So we're going to be looking at that closely So ensure as you're scoping your project or the scope that you're presenting to work here at ESIF, there is proper funding and support for that. So for the merit review criteria, again, that's the criteria we're going to be using. That's going to be evaluated by both NREL and DOE management. And to be considered, you must meet all the eligibility criteria and have an application package comprising of all the required materials that I went through in the proposal package slide. Once you have that all together, they must be sent to userprogram.esif@nrel.gov, and then we'll distribute that for the merit review. And again, those will be reviewed on a rolling basis, so please allow for 4 to 6 weeks for a response. And a special note here at the bottom of the slide that selections will be made at the discretion of NREL management based upon the merit and available resources. So as I mentioned, becoming very familiar with the labs, the equipment and resources that are available to ESIF, we're going to be looking at those that you propose to ensure that they are available for your research project. So being very specific on what you'll be intending to use is very important. So once we conduct the review and then NREL and DOE management agree that your application is an application and a project that we would want to pursue collaboratively here at the ESIF, we'll begin the contracting process. And again, on the opening slide, it's 4 to 6 weeks for that process. And all work is going to be non-proprietary. All the results will be shared publicly, and our technology transfer office will work with you to select the appropriate agreement mechanism. And if you're curious and like to know more about the type of agreements that we execute here at NREL, I'm not going to read it, but this is available to you, the Working With Us section, and then the Technology Partnership Agreements site on nrel.gov. So those are the main components of the call, the goals, objectives, the type of information that we'll need from applicants for us to conduct our merit review and selection process. And so now I want to dig in more on the capabilities in the Energy Systems Integration Facility. So if you haven't been out to NREL and able to visit the ESIF, we always invite folks to come and tour to learn more about the work and the capabilities that we do here at the laboratory. So the ESIF is a national user facility, again, located on the NREL campus in Golden, Colorado. Again, it hosts a collection of interconnected laboratories that accommodate a megawatt scale research and development and full power. We're one of a few facilities across the country that can accommodate that type of work. And our focus is on modernizing the electrical grid and beyond. And again, we're focused on integrating multiple energy systems, including water, thermal energy, and fuels. And so now we're going to talk more about the capabilities in the laboratories here at ESIF. And so this slide, and I'm not going to spend too much time on these next slides because, again, I think the best way for you to learn is to go to the ESIF tour URL that I showed earlier, because you're going to be able to spend the appropriate amount of time looking at those capabilities and resources. But I did want to highlight some of our main resources here in the laboratories on the webinar. So you'll see here a layout of the ESIF and 4 different colors. And those 4 colors represent the systems. So red is the electrical system, orange is the thermal system, blue is the fuel system, and then purple is the high performance computing, data analysis, and visualization components. And so this describes a little bit more of the capabilities that are across the ESIF. So we have electrical, and we can connect various power equipment up to 2 megawatts using our research electrical distribution bus, which I'll highlight on the next slide here. We have hydrogen laboratories. They're interconnected, so we do a lot of fuel cell development, test, and manufacturing. Energy storage, again, the thermal includes the site-wide cold water and hot water thermal loops for research applications. So looking at cogeneration, equipment cooling, combined heat and power hardware in the loop, and then we have several environmental chambers throughout the laboratories to replicate conditions that equipment would be seeing, kind of extreme ends of the spectrum as these new technologies are deployed out in the field. So we're going to be looking at the research electrical distribution bus next. The research electrical distribution bus here, you'll see in the bottom right corner, REDB, and then grid sim. So our grid simulation capabilities is 2 megawatts, and we can then attach through the research electrical distribution bus, we can hook up power, electronics, and other equipment to the grid simulator and connecting these different laboratories that you see here. So the idea is that you don't have to have a piece of equipment in a specific lab for it to be incorporated into your research and development project. We can connect resources and equipment in multiple laboratories to build, again, a megawatt scale R&D project. And so REDB is comprised of AC, 2 AC and 2 DC buses. So we have a 250 amp and 1600 amp AC bus, 250 and 1600 amp DC bus. You can see the specifications here. And at the bottom, you see it connects the different laboratories that it connects. So Power Systems Integration Laboratory, our Systems Performance Laboratory, which is where we have testing and equipment for residential systems. And again, we have this information on the website so you can really dig in and learn about REDB and its capabilities. So this is a slide on the architecture, ratings, and performance for our grid simulator. So we have 12 AMETEK RS-90 units connected in sets of 3 to make 4 different quads. And you can configure any combination of those quads to meet the requirements and enable your research projects. So our PV simulator, which you can also connect through the research electrical distribution bus, connect to our grid simulator. It's a 1.5 megawatt DC power supply. And that comprises of 6 MagnaPower MTD 1000 to 250 units. And those are configurable in series or parallel up to 1500 amps DC or 4000 VDC. So what we're showing here is ESIF capabilities and equipment is configurable in many different ways and in ways that allow the testing to be done to address all types of scenarios and grid conditions that would be experienced in the field. And the intent of being able to configure in all these different methods is testing equipment at power ratings that they would need to demonstrate in the field, but also it's a way to reduce the risk for manufacturing, industry partners, and utility partners to test this equipment at scale under multiple scenarios before they're installed on a live distribution network. So this is our PV battery DC simulator. It's a 0.66 megawatt Anderson unit. It's a liquid cooled device. And so this is what we're, if you need to connect and simulate batteries as part of your research experiment. The Anderson unit is one of our go-to pieces of fixed equipment. And then outside, we have two outdoor testing areas, a low voltage outdoor testing area and a medium voltage outdoor testing area. And this slide here is out at our low voltage outdoor test area. So we have 1.1 megawatts of controllable AC load banks, and these are also connected through our research electrical distribution bus. So it gives you an additional capability to test equipment, to run your research with utility scale load banks. And then utility scale is very important for us here. So we have utility scale PV and battery inverters. And I say that's very important for us because at ESIF, we're looking at scalability. So testing power electronics and other connected systems and being able to demonstrate how these can scale, and then how the controls and commands can ensure that as you scale up those technologies, that they're operating in the way that a utility would require and an equipment manufacturer would, want to achieve. So utility scale fixed equipment, such as our inverters, are very important. So we want to make sure that you realize that those are here and available. And battery energy storage resources, you see 3 of them here. We have a Caterpillar, A123, and a CES battery storage units. And then diesel generators. These are also outside at our low voltage outdoor test area. So I mentioned before, at ESIF, we are working to ensure how distributed and renewable energy resources can incorporate into existing technologies such as diesel generators, natural gas supply. So we have natural gas going through our laboratories, and then diesel generators, because we want to make sure that, again, we're looking at a full systems approach to incorporating conventional resources, legacy equipment with these new technologies. And then the research electrical distribution bus, and then the equipment that I just showed you allows us to do the power, hardware, and the loop research. And so I'm not going to spend too much time on this, but again, this approach is key to work here at ESIF. So as you go through the ESIF laboratory tour, you'll better understand our grid simulation and modeling capabilities, how we can run models that power the devices under test, and then see how those pieces of equipment respond, and then go through a continuous learning process using real equipment, real-time data to optimize that equipment and optimize those systems, make adjustments to the models as needed. And then in the back portion of ESIF, I had mentioned that we have interconnected fuel cell, thermal, and hydrogen testing laboratories. So this is a highlight of some of the facilities. So on the right, you see the NREL stack test bed, where we're producing 50 kilograms per day of hydrogen. And that hydrogen then is piped through our fuel cell test laboratories. And then it's compressed and stored outside. You can see our storage area here. And then top left, we have fuel cell vehicle refueling and testing facilities. So it's a very comprehensive hydrogen production, compression, distribution, and testing capability here at the laboratory. And one of the projects that we have right now, which you can learn more about on the ESIF webpage, is a biomethanation system. So this is part of using renewables to generate other energy storage mediums, such as natural gas. So it's a electrons to molecules approach, and it's work that we're doing here at ESIF to work with utilities to understand how we can maximize the generation of increasing amounts of renewables on the system by converting that to other products such as natural gas or hydrogen. So happy to answer any questions, and those slides I just presented on the ESIF capabilities are certainly a lot of technical information built into that. But again, the best source of just reading through and understanding the technical capabilities and resources that would be available to you are going through the facility tour on the ESIF website. So again, that's nrel.gov/ESIF/facility tour. So as you're going through those web pages, then you can email the user program here for questions on those specific resources and capabilities, in addition to any questions that you would have on the application and proposal package that you'd be developing through this opportunity.
Okay, great. Well, thanks, Andrew. It looks like we don't have any questions coming in right now. So as Andrew mentioned, just go ahead and send your questions to the user program email that's up on the screen right now. Just want to thank you guys for joining us today, and thanks, Andrew, for your time. And do want to let you know that since we recorded this webinar, we'll be making that available on the website as well. Hope everyone has a great day. Thanks for joining us. Bye-bye.